So hello students, welcome to this computer class. This will be the last class for chapter 1. So in the previous classes we have discussed the conversion of different number system to different other number systems like decimal to binary, binary to decimal, decimal to octal, then octal to decimal again, decimal to hexadecimal and hexadecimal to decimal. Today in this class we will be discussing about octal to binary conversion, then hexadecimal to binary conversion, and back to octal and hexadecimal from binary. Okay, so before studying all these things, you need to know the how to calculate the binary numbers, or how to add the binary numbers. Suppose we have one binary number, suppose uh, 0, simply. Okay, 0 plus 1. 0 plus 1 means how much? How much will be the value? 0 plus 1. 0 plus 1 will be how much? 1, right? Again, 1 plus 1, how much? It should be 2. But do you have 2 in binary numbers? No, we do not have 2, right? 2 আছে নেকি binary numbers ত? 2 নাই, হয়নে নহয়? আমি decimal number এটা যেতিয়া লিখো, decimal number এটা লিখিলে কেনেকে লিখো? When we write a decimal number, how do you write a decimal number? We write the decimal number this way, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? We write this way. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 10 symbols or 10 digits. After this 10 digits, what happens? We write 10, right? Similarly, in case of octal number, what we write? 0, 1, 2, 3, 4, 5, 6, 7. Until 7, all the symbols or all the digits in octal number system are over. And after the symbols are over, what we write? We write 10, right? We write 10. So again, in hexadecimal number system, how do you write the numbers? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many symbols are there in hexadecimal numbers? 16, right? 10 plus 6 equal to 16. So here are 10 symbols. So these are 10 symbols similar to that of the decimal number system, right? There are 10 symbols at first. Then after that, what happens? What comes? A, comma B, comma C, comma D, comma E, comma F. That is six symbols. So total 16 symbols. And after that, what comes? 10. So from all of these, you could see that this is also 10, right? Wait. This is also 10. This is also 10. So when the symbols in a number system is over, then what comes? 10. Okay? Symbol কেইটা যেতিয়া শেষ হয় তেতিয়া কি হ'ব? আমাৰ 10 আহে সবতে। ইয়াৰ পিছত কি আহিব? 11, 12, 13, 14, 15, 16, 17, 18, 19. Then what will come? 20, right? 20. After 19, how much will be the number? That is 20. Because 9 is the last symbol, right? So here also, after like this 11, 12, 13, then until 17 it will come. Then after 17, what will happen? We have to write 20, then 21, 22, 23, like this again. So here 10, 11, 12, 13, 14, then 1F will come. Then after that, how much? 20 will come. Okay? So in this way, the numbers proceeds in the different number systems. Okay? So then how the binary number system will work? So in binary number system, there are two symbols or two bits, 0 and 1. And after that, what happens? What will come? Here the symbols are over, right? So what will come? 1, 0. Similar to all these number systems, right? So after 0, then 1, then 1, 0. That means this is in which position? This is in which position? It is in second position. That is 1 plus 1 equal to, in binary number system, is 1 0, which is equivalent to 2 to the base 10. Okay? Okay? So 1 plus 1 equal to how much? 1 0. Then plus 1. If we add one more, then what will happen? 1 1. Then plus 1. What will happen? 1 plus 1, 1 0. 0 will be there, 1 will be carried forward. Then 1 plus 1, again 1 0. So 1 0 0 to the base 2. So this is how we add two binary numbers. Okay? So this is how we add two binary numbers. So this will be very important, very much required in order to solve the other problems. Okay? So we have octal to binary conversion. In this conversion, check out what is written in the book. Turn to page number 23. So in page number 23, we can see that since there are only 8 digits in the octal number system, 3 bits are sufficient to represent any octal digits in binary. So in order to represent any octal numbers, because since octal numbers or octal number system has 8 bits, 8 bits means, sorry, 8 digits means we can write this 8 as 2 to the power 3, right? 2 into 2 equal to 4, 4 into 2 equal to 8, right? 2 to the power 3. That means only 3, only 3 bits will be required to represent any octal number. Okay? So remember this. ঠিক আছে? তোমালোকে এইটো মনত ৰাখিবা যে যদি আমাৰ ওচৰত 8টা ডিজিট থাকে যিকোনো এটা নাম্বাৰ চিষ্টেমৰ, অক্টেল নাম্বাৰ চিষ্টেম বুলি নাই ধৰা বাদ দিয়াটো, যদি আমাৰ ওচৰত 8টা নাম্বাৰছ থাকে, 8টা চিম্বল থাকে, এই 8টা চিম্বল আমি কিহেদি ৰিপ্ৰেজেন্ট কৰিব পাৰো? 3টা বাইনাৰী বিটছেদি ৰিপ্ৰেজেন্ট কৰি দিব পাৰো। কেনেকৈ কৰিম? কেনেকৈ কৰিম আমি পিছত গম পাম। এতিয়া গম পাম, ৰবা। We will come to know when we do the conversion first. Okay? So, in order to convert the octal number into binary equivalent, the procedure is to convert each octal digit to a 3-bit binary equivalent. So, in order to convert an octal number into its binary equivalent, that is, an octal number to a binary number, how is the procedure? What is the procedure? The procedure is to convert each octal digit to 3-bit binary equivalent. Okay? Suppose here we have 24. This should be there, right? This is the octal number. How do you know this is the octal number? Because there is 8 as base, right? If we have to convert this octal number into binary number, then what we will do? First we will take 2. We will convert 2 into its equivalent 3-digit binary number. So how you will convert 2 into its equivalent 3-digit binary number? So in order to do that, you have to know another thing. You have to know the table. You have to know how to create a table. How to create a table that contains all the different number systems, right? Okay, so let's create a table first. So here is, just wait. I'll show you in a different format. Suppose in Word, I'll try to write it in MS Word. Okay. Now we have to learn this MS Word also, right? We have to learn this too. So when I will be showing you this, you just remember how I'm using this. You just look how I'm using this. Okay. So this. Okay. So I go to insert table 1, 2, 3, 4. So okay, we need only 4s. Okay. So here is decimal number system. Then when I press tab, it will come to the next cell or the next column. So decimal. So here we will write octal. here we will write hexadecimal, and here binary. Okay, so in case of decimal number system, there are what? Zero. Zero is there, right? Is it not? Zero is there. Then for zero, the octal equivalent will also be zero. So what is zero? আছে হয়নে নহয়? Zero, zero. Okay. Next. Sorry. Next. Next. One is there in decimal. One is there in octal too. One is there in hexadecimal. One is there in binary. So next. 2 is there in decimal. 2 is there in octal. 2 is there in hexadecimal. 2 is not there in binary. We need to write how much? 10. Okay. That means 1 plus 2 equal to 1 plus 1 equal to 1 0 in case of binary numbers. Okay. So next, 3. 3 is there. 3 is there in octal 2. 3 is there in hexadecimal 2. But here we have to write 1 1. That is 1 0 plus 1 equal to 1 1. We did that before, right? 1 plus 0 plus 1. How much it was? Sorry. So 0 plus 1, how much it was? It was 1. 1 plus 1, it was how much? 1 0. 1 0 plus 1, how much? 1 1. 1 1 plus 1, how much? 1 plus 1 equal to 1 0. 0 will be there, then 1 is carried forward. 1 plus 1, 1 0. So that means this is 1, right? This is 1. This is 2. This is 3. Right? 3 means 1 1. 4 means how much? 1 0 0. Right? So we write it in this manner. So 3 means 1 1. Right? So here 4 means there are 4 in decimal. There is 4 in octal. There is 4 in hexadecimal. But here we need to write 1 0 0. That is, we will add 1 to 1 1. Okay? So next 5 is there. 5 5 1 0 1. Okay? I'll write this in speed, so you can calculate this again. You just add 1 to each number. Suppose in order to get this number, you add 1 to this. Then again, in order to get this number, you add 1 to this. Okay? So 6 is there, 6 is there as well, 6 is there as well. Then here 1 1 0 is there. So 7 is there, right? 7 is there in octal also, 7 is there in hexadecimal. Here 1 1 1 is there. Okay? Next. 8 is there in decimal number. Is 8 there in octal number? No, 8 is not there in octal number. So we need to write when the symbols are over, we need to write 1 0. That is 10. So here 8 is there, right? So here 1 0 0 0. 9 is there in decimal number. Here after 10 we get 11. So here after 8 we get 9. So here 1 0 0 1. Next. The decimal numbers had only 10 symbols, right? So 0 to 9. Then when the symbols are over, what do you have to write? We have to write 10, right? So here after 11 what comes? 12. Then after 9 in hexadecimal number, what is there? A is there, right? A. Sorry. So in binary number, what will be the next number? 1 0 1 0. Okay. Then 11. 13. B. That is 1 0 1 1. Next 12. 14. C. 1 1 0 0. 15. No, sorry. 13. 15. D. 1101, 14, 16, E, 1110, 15, 17, F, 1111, 16. Here, how much will be the next value? What will be the next value? Here 1 is there, 2 is there, but after 7, what will come? It is 0, right? So we need to write here 20. Here we have to write 10 because symbols, all the symbols of hexadecimal number are over till F. Okay, so next is 10. So here how much? 10000. So next 17, 21, 11, 10001. So in this way you can create the table. Okay, the conversion table, and you need to learn how to create this table, how I am creating this table. You check the video again and again and try to make this table on your own. Okay, so next let's go back to the lesson or the chapter. So this, okay, octal number. So 2, for 2 means how much? 2 means 2 in octal number is binary how much? 10. So it will be 10. 4 means how much? 4 means how much? 4 means 100. 100. But we know that we need 3 bits. Okay? We need 3 binary equivalent. 3-bit binary equivalent for each digit. So here we have only 2 digits, right? So we need to add 10 before it so that we get 3 digits here. Okay, so here the answer will be for 24 to the base 8. The equivalent binary number will be how much? 0, 1, 0, 1, 0, 0 to the base 2. You can omit this 0. Okay, so you can omit this 0 because on the left side 0 has no value, right? So 1, 0, 1, 0, 0 to the base 2 is the answer for 24 to the base 8. Okay, so this is how we convert an octal number to binary number. Okay, so 1, 0, 1, 0, 0 to the base 2. Let's convert this back into octal number. 1, 0, 1, 0, 0. Let's convert this back into octal number. Okay, so how you will convert this? কেনেকৈ convert কৰিবা octal number হলে? আমি গম পাইছিলো কি প্ৰত্যেকটো octal digitক 3টা binary bits হলে ভাগ কৰা হয়. That is why here ইয়াতে কি কৰিম আমি এই right side ৰ পৰা 3টাকে group বনাই লম. Okay, right side ৰ পৰা 3টাকে group বনাই লম. Group কেনেকৈ বনাম? 0 0 1 0 1 ইয়াত আৰু এটা আছে জানো? নাই. তো গতিকে আমি কেনেকৈ লিখিম? 0 0 1 তিনটা এটা গ্ৰুপ বনাই ললো 0 1 0 এটা আগত বহাই ললো একো প্ৰবলেম নাই হয় না তো ইয়াৰ ইকুইভ্যালেন্ট ডেসিমেল নাম্বাৰটো বা বাইনাৰী নাম্বাৰটো আমি লিখি দিম অক্টেল নাম্বাৰটো লিখি দিম 100 মানে how much it is 4 10 means how much it is 2 so the equivalent octal number will be 24 to the base 8. Clear? Okay. You try some questions like 65 to the base 8. You convert into octal. Then, you convert it into binary. Then again, convert back the binary into the octal number. Okay? So 65 to the base 8. 123 to the base 8. You convert this as well. Okay? So these two are your homework. These two are your homework. Okay. So binary to octal, we already discussed how to convert the binary number into octal number. Okay. So you convert this directly, or you can do this as well. All right. So if you do not remember this table, so you can do like this. Okay, 101, you convert it into decimal first, then you can use that in your problem sum. Okay, so if you use the decimal number, if you do not know what is the value of 10100, you can convert it like this, right? 1 into 2 to the power plus 0 into 2 to the power 0 into 2 to the power 0 plus 1 into 2 to the power 1 plus 0 into 2 to the power 2, like this. Is it not? 0, 1, 0 to the base 2 equal to how much? This one, right? Equal to how much? This is 0, this is 2, this is 0. Okay, so here we get only 2, right? Here we get only 2. So for 100, how much will be the answer? 1 into 2 plus 0 into 2 plus 0 into 2. So here it will be 0, here it will be 1, here it will be 2. So any number into 0 is always 0, so here we will get 0 only. So 1 into 2 to the power 2, 2 to the power 2 means 4. So we'll add this all this. So what we'll get? We'll get 4. So 2 to 4 to the base 8 will be the answer. Okay? So we convert it this way, right? Now hexadecimal number. Suppose since there are 16 digits in hexadecimal number, in in octal number, how many digits were there? There were 8 digits, right? There were 8 digits in octal number. So 8 equal to 2 to the power 3. That is why we required 3 bits. We required 3 bits. We required 3 bits, 3 binary bits to convert to represent. We require 3 binary bits to represent a octal number. Okay? But here we have 16 symbols. So 2 to the power 4. 2 to the power 4 is 16. So we'll be needing 4 bits. So we will be needing 4 binary bits in order to represent a hexadecimal number. Okay? So we will write it in this way. So we'll convert any hexadecimal number. Suppose let's say an example. Uh, let's start with a small example. Then we'll try to solve this. Okay? So let's start with a simple example. So suppose we have suppose 43. Suppose we have a number 43 to the base how much? 16. We need to convert this into binary number. Okay, we need to convert this into binary number. So how you will convert this? We know that we have to 4 and 3. We have to convert each of these numbers, each of these hexadecimal symbols or numbers into 4 equivalent binary bits. So 4 means how much? 4 means how much? 2. 2 2s are 4. 0. 2 1s are 2. How much? 0. So it will be 1 0 0. For 3, 3 means how much? 2 ones are 2. Just write, 2 ones are 2. Then after that, what happens? 2 ones are 2. So 1 will be the remainder. So it will be 1 1. But we know that. Each hexadecimal number will be converted into 4 binary bits, 4 equivalent binary bits, right? So we need to add 2 zeros before this number and 1 0 before this number. So then we will get this number 0 1 0 0 0 0 1 1, which is the binary equivalent of 43 to the base 16. Okay, is it clear now? So is it clear now? Let's try the example that we had in our book. Okay, let's try that example. So the number is 2ac to the base 16. Okay, let's try this one. 2ac to the base 16. Okay, let's make the 16 smaller, not that small. Let's make this bigger. Okay, okay. 2ac to the base 16. We need to convert this into its binary equivalent. Okay, so how do you do that, right? So first of all, you know that you can see that we have 3 digits, right? We have 3 digits, 2ac. Okay, we have 3 digits, 2ac. So first of all, we will convert this 2. So we know that 2 means how much? 1 0. So we can calculate this as well, or we can calculate this directly. We can convert this as well here, 0. So 1 0. Okay, 2 equal to 1 0. So a, how can you convert a? A means a is equivalent to what number of decimal number? Let's see the decimal number. A is equivalent to how much? 10. A is equivalent to 10. 10 of decimal number. 10 to the base 10. Right? So we need to convert this 10 into binary equivalent. So 10 we will divide by 2 in order to convert it into binary equivalent. প্ৰথমতে আমি a to convert কৰিব লাগিব decimal le. Decimal le আমি a মানে কিমান বুলি জানো 10 বুলি জানো হয় নে নহয় তো 10 to তাৰ পিছত আমি binary le convert কৰিব লাগিব 10 to binary le কেনেকৈ convert কৰিম 2 2 4s are 8 or 2 5s are কিমান হ'ব 10 0 2 2s are 4 1 থাকিলে 2 1s are 2 0 থাকিলে so what will be the result 1 0 1 0. So 1 0 1 0 is the binary equivalent for A. Similarly for C, A is 10, B is 11, C is 12. B will be 12, right? Similarly, we will have C. C means how much? C means 12. Okay, 12 of decimal number, right? 12 is a decimal number, right? C is what? Hexadecimal number. C is a hexadecimal number and 12 is a decimal number. Hexadecimal of C is equal to 12 of decimal number, right? So now we have to convert this into binary equivalent. So how you will convert this? 12, write it this way, 12. So we'll divide by 2, 2 6 are 12, so remainder is 0. 2 3s are 6, so remainder is 0. 2, 1s are 2, so remainder is 1. So 1 1 0 0, 1 1 0 0. This is the binary equivalent of this number, that is C. This hexadecimal number, that is C. Okay? So here, as we know that each hexadecimal number should be converted into 4 binary equivalent digits or bits. Okay, so here we already have 4 bits, here we already have 4 bits, here we have only 2 bits. So we can add 2 zeros before this, but we do not need this because adding zeros on the left side, on the far left side, is not required. Okay, so the answer will be how much? 1 0 1 0 1 0 1 1 0 0 to the base 2. This will be the answer. Let's check the book. What is written in the book? See, 1 0 1 0 1 0 1 1 0 0. Right? This is what it looks like. Okay? 2AC means this binary number. Okay. Now let's try to convert it back to the hexadecimal equivalent. Okay, let's try to convert these numbers back to hexadecimal equivalent. So, okay, let's delete this. So we'll write this here: 1 0 1 0 1 0 1 1 0 0 to the base 2. Just look carefully if it is if I have written the numbers correctly or not. 0 0 1 1 0 0 1 1 0 1 0 1 0 1 0 1 0 1 0 1. Okay, it is correct, right? So we need to convert this into its what, hexadecimal equivalent, right? Hexadecimal number. So what we will do? So what can we do? Wait. So what can we do? First of all, what do you have to do? First of all, you have to group this number from the right side into 4 numbers. Okay? Four numbers or 4 digits will create one group. Okay, so next 4 digits will create another group. So next 4 digits should create another group. So we can add 2 zeros over here. So we can make the 7, right? So what is the decimal equivalent of this? What is the equivalent of these numbers? We need to write those. Okay, so 1100 means how much? 1 into 2 plus 1 into 2 plus 0 into 2 plus 0 into 2. Okay, this is 0, this is 1, this is 2, this is 3. So this part will give us 0 plus 2 to the power 2 equal to 4, 4 into 1 equal to 4. So we'll get 4 over here. So here 2 to the power 3 equal to 8, 8 into 1 equal to 8. So 8 over here. So 8, 9, 10, 11, 12. We will get 12. Okay. So here, what we will get? This is 1, 1, 0, 0 equals this one. Okay. So 1, 0, 1, 0. So what we will get over here? 1 into 2 plus 0 into 2 plus 1 into 2 plus 0 into 2. It is very difficult to write with this mouse. Okay, that is why my handwriting is not very good over here. Handwriting is কাৰণে ভাল হোৱা নাই, mouse লিখিবলৈ বহুত দিগদাৰ. But I will try to write it properly so that you can understand. Okay, so this is 1. If you do not understand anything, please ask. Okay, 1 into 2 to the power 1. Here this is 2 to the power 2, right? This is 2 to the power 3. Okay, so 0 into any number is always 0 plus 2 to the power 1 means 2. 2 into 1 equal to 2 plus 0 into any number is 0 plus 2 to the power 3 means 8. 8 into 1 equal to 8, right? So 8 plus 2 equal to how much? 10. We will get 10 over here. So here we are having 10. So next 10. How we will calculate this? 1 into 2 plus 0 into 2. 2 to the power 0, 2 to the power 1. So how much will be the value? This is 0 plus this is 2. So 2. So here we will get 10 and here we will get 2. So these are what? Decimal equivalents, right? This decimal equivalent. This is decimal equivalent, right? So 12, the decimal number 12 represents what of hexadecimal number? It represents how much? C. So we'll write C. For 10, 10 of decimal, it is A, right? For 2, it is always 2. Okay, so the equivalent uh, hexadecimal number for this binary number is how much? 2 AC to the base 16. Okay, let's make it bigger so that it will be easily, it can be easily seen. Okay, 2AC to the base 16, right? This is the answer. Okay, so we learned how to convert octal to binary and binary to octal again. And we also learned how to convert hexadecimal number into binary and binary number into hexadecimal again. Okay, so now let's try to convert a hexadecimal number into what? Into octal number. Okay, let's try to convert a hexadecimal number into octal number. So here I will write hexadecimal to octal. Okay, I'll write it as hexadecimal to octal. Let's make the color different so that it can be easily made. Okay, to hexadecimal to octal. Let's give a line. Okay, hexadecimal to octal. We have this number, this hexadecimal number 2AC to the base 16, right? So 2AC to the base 16. We will convert this into its octal equivalent, right? We'll convert this into, oh sorry, we will convert this into octal. Okay, so how you will convert this into octal? So in order to convert this into octal, first of all you need to convert it into binary first. Then after that it can be converted to octal. Similarly, in order to convert octal to hexadecimal, first of all you need to convert the octal number into binary and then the binary number into octal number. Okay, hexadecimal number. All right, so here is how to do that. So 2AC to the base 16, 2AC to the base 16. First of all, you need to convert this number into binary number, right? So how will you do that? So we already know this binary equivalent of this. We will not calculate it again. So you can just convert it. 2 means how much? 1, 0. A means how much? 1, 0, 1, 0. And C means how much? 1, 1, 0, 0. Okay, these are the binary equivalent for these numbers, right? So 0, 0. Okay, as we know that from hexadecimal number, if we convert it into binary number, then we For every hexadecimal digit, we get 4 equivalent binary bits, right? So again, we know that for converting binary number into octal number, what we have to do? We have to take, we have to pair 3 bits from the right side. We have to pair 3 bits each for the binary number in order to convert into octal number, right? So 100. Here we have what? We have paired these things, right? 100, 3 binary bits. Here 101, 3 binary bits. 010, 3 binary bits. 001, 3 binary bits, right? So now we can convert it into octal number. So how we will convert? 100 means 1 into 2 to the power 2 to the power how much? 2 to the power 2 plus 0 into 2 to the power 1 plus 0 into 2 to the power 0. This will be 0 plus this will be 4. So this will be 4, right? 100 means 4. 101 means how much? 5, right? This will give us 5. So you can calculate it as well. 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. 2 to the power 0 is always 1. 2 to the power 0 is 1. So 1 into 1 equal to 1 plus 0. 0 into any number is 0 plus 2 to the power 2 equal to 4. 4 into 1 is always 4. So 4 plus 1 equal to 5. Okay. 4 plus 1 equal to 5. So 5. So here 1 0 means how much? 0 1 0. 0 1 0. That means only 1 0, right? So 1 0 means we already know that it is 2. You can calculate it as well. So 0 1 means how much? 1. So this will be your octal equivalent of this number. That is 1254 to the base 8. Okay, 1254 to the base 8 is your octal number. Okay. Now you can also convert this octal number into hexadecimal number. Just rotate this, right? So for 4, you need to convert it into 3 binary bits. Then for 5, you need to convert into 3 binary bits. For 2, you need to convert into 3 binary bits. Then 1 into 3 binary bits. Then after that, you combine 4, 4 numbers into a group, 4 numbers into a particular group. Then you convert these 4 numbers into 1 into single hexadecimal digits. Okay, this is how to convert hexadecimal to octal and octal to hexadecimal numbers. Okay, so I think till now it is all clear for you all. I haven't received any queries from you or any doubts from you. You haven't asked me about any doubts. Okay, so I think everything is clear for you till here. If you have any doubts or if any doubt arises in the later time, so you can ask me directly, you can call me, or you can send text messages in the WhatsApp group, right? So thank you for today. Uh, you start writing the question answers, okay? So I will also give you some of the question answers. So you also write the question answers and you can upload that in the WhatsApp group so that I can evaluate those question answers, right? So thank you for today.